Okay, so I've been having some questions and some of the same questions coming up, so I thought I'd work out a few more problems and see if this helps at all in your solving. Let's first look at a graphing. Remember graphing last week, we want to make sure that if we have both x and y in our equation, that we have solved for y. So let's look at this first equation here. And if you look, it's not solved for y yet. So I'm going to rewrite it down here. X plus 2y equals 6. And I'm going to get y by itself. So I'm going to start moving everything away. Remember, we moved the x term first. So you're going to subtract x from both sides. So that's 2y equals negative x plus 6. Remember, I'm putting the x first just so it's in the form we want it to be in. And now we're going to divide everything by 2 so that y is by itself. So we get y equals, now be careful here, so x, I'm going to write, but let's see what's in front of it. Okay, there's an understood 1 right here, right? So that's a negative 1 over 2 for our slope. And then 6 divided by 2, well, that's just 3. So if we have it in slope-intercept form, the number, the constant, the number by itself at the end, that's your y-intercept. So that's where it crosses the y-axis. The slope is negative 1 over 2, so down 1 over 2, down 1 over 2. Or we could go up 1 and back 2, couldn't we? Either way, okay? And then we can draw our line. Now the other line does not have a y. It only has an x. So what do we know about a line that only has an x and no y? Well, remember the acronym VUX. If it's x equals a number, it has an undefined slope, and it's a vertical line at x equals 4. So x equals 4 right here. So I'm going to draw a vertical line, and then my solution is where they cross, which is right here at 4, 1, and that's your solution. So hopefully that helps a little bit with graphing. Now let's go down to substitution. I'll cover a couple of substitutions in this one as well. Okay, so substitution. Now this is the one where I want to have one of the equations solved for a variable so I can plug it into the other one. Seeing how this first equation, see, it looks like it'd be very easy to get x by itself. Let's do that. I'm going to come down here and I'm going to rewrite that first equation. And I'm going to get that x all by itself. So to get it by itself, I would need to get the negative 7y moved. So to move it to the other side, I'm going to do the opposite. So that means I'm going to add 7y to both sides. So we have x equals 7y minus 21. Now what that does is I now have that x is the same thing as 7y minus 21. That means instead of x in the other equation, I can plug in 7y minus 21. So I'm going to rewrite this second equation right here. But instead of x, I'm going to write 7y minus 21. So we have 2 times, but instead of x, 7y minus 21 minus 14y equals negative 42. So 2 times 7y is 14y. 2 times negative 21 is negative 42. Now, do I distribute the 2 to the negative 14y? No, because remember, it's not in the parentheses. I only distribute the 2 to whatever's inside the parentheses, so this just hangs out right here. Okay, now I've got like terms on one side, so I need to combine them. 14y, negative 14y, well, those are going to cancel out. So all I have over here is negative 42 and negative 42. Okay, this is one of the special cases. Remember, if when you're solving systems of equations out, if all of the variables cancel out, I have either a no solution or a infinite solution. So what I've got to decide is, well, when they all cancel it out, did they give me a true statement or an untrue statement? Well, this is true. Negative 42 is equal to negative 42. That means I have infinite solutions. That means that these two, if I were to graph them, are the exact same line. And that's all you have to say. Or you could do, remember the sideways 8 that we talked about? Okay, so this happens sometimes. If you're graphing, it's going to look like the exact same line, and that means they touched the whole entire way, and any point on that line would be a solution. All right, let's try one more substitution. Okay, so on this one's set up perfectly for us to do substitution. It already has a variable by itself. It says that y is the same thing as -5. So all I've got to do is in the other equation, where you're plugging in the other equation, where I have a y, I'm going to plug in -5. Okay, so I'll rewrite this. 8x, I'm just taking this second equation and I'm plugging that in. Plus 5 times, but instead of y, I'm writing -5 because this equation right here tells me they have the same value. Y is the same thing as -5, so I can substitute -5 in place of y. So we have 8x, 5 times -5 is -25. And now I can just solve for x. So I'm going to move the constant first. We're going to add 25. So we have 8x equals -17 plus 25 is 8. I'm running out of room. If we push this up a little bit, divide both sides by 8, then x equals 1. Well, normally I would need to then plug 1 back in to solve for y, but guess what? They already told us what y equals. So this one's done. X is 1 and y is -5. All right, hopefully this helps a little bit. Hopefully these look familiar if you have your worksheet out. And I will post another video going over elimination as well. Good luck. Let me know if you have questions.